Okay, I want to work through problem 2 in a slightly different way. Instead of thinking strictly about probabilities, I've redrawn the tree slightly differently than I had it before, but it's the same setup. We have an individual with a new mutation here, I'm drawing with an arrow, capital M, small m, who has a partner who is capital M, capital M. They have a daughter, individual 1, who then has kids with someone who is capital M, capital M. Now, let's think about the different possibilities for her first kid, individual 2. So instead of thinking about it just in probabilities, let's imagine we have 1,000 families. We start with 1,000 families that all have exactly the same structure. Now, we know from before that in 500 of those families, individual 1 will be capital M, and in 500, the remaining 500, individual 1 will be capital M, small m. Now, let's think about individual 2. If the mother, individual 1, is capital M, then we know that individual 2 will always be capital M, and individual 3 will always be capital M. So we have 500 trees or 500 families in which this last generation, we have individual 1 is capital M, her partner is capital M, and because they only have capital M's, both of their children are capital M. Okay, so that's 500 times. Now, if individual 1 happens to be capital M, small m, then she's going to have a 50-50 chance of having a kid who's capital M, or capital M, small m. So 250 times her first kid is going to be capital M, and 250 times her first kid's going to be capital M, small m. And then since individual 2 and 3 are independent, if we look at individual 3, then if the first kid was capital M, half the time, the second kid's going to be capital M, that's 125 times. The second kid here could be capital M, small m, that'll happen 125 families. If the first kid is capital M, small m, the second kid can be capital M, also 125 times. And similarly, they can both be capital M, small m. So now we have a bunch of different families. We have, sorry, I'm going to write this a slightly different way just because it's a little confusing. Let's just sum it up, summarize it down here on the bottom. 500 times the genotypes are capital M. 125 times we go capital M, small m, capital M. 125 times we go capital M, small m, capital M, small m. 125 times we go capital M, small m, capital M, small m, capital M, and 125 times we go capital M, small m, capital M, small m, capital M, small m. Right, so on the left here, the cases where there's 500, those are the possibilities if individual 1 is capital M, and then we have these more complicated possibilities if individual M is capital M, small m. So now, if is in the problem, I tell you something, which is that individual 2 is capital M, we can cross off all of these possibilities where individual 2 is capital M, small m. So I'm crossing off in purple these cases where where the individual 2 doesn't match what I tell you. And so we're left with only these families. And so now we can look at these families and see, and remember the question is, what is the probabilities for the genotypes of individual 3? And we see that of the remaining cases, 500 times, we have 500 families that are all capital M. So in those cases, individual 3 is capital M. So that's 500. Then we have 125 cases where individual 3 is capital M, but has a mother who is capital M, small m. But we have to count those because those are, we're only concerned with the genotype of individual 3. And then we have 125 cases where individual 3 is capital M, small m, even though individual 2 is capital M, and the mother is capital M, small m. So that's the other possibilities. So we look at this, we have 500 plus 125 is 625 cases, 125 for capital M, 125 for capital M, small m. So the probability that this individual is capital M is equal to 625 out of 625 plus 125, which is equal to 5/6.